Pluto's direction has forever been a subject of interest and worry. From the start, Pluto's circle has converged with that of another planet, which normally brought up issues. Pluto, the cryptic and little divine body arranged in the farthest reaches of our nearby planet group, has turned into a successive subject of conversation in the field of cosmology. Ongoing disclosures have ignited caution, showing a potential impact with Neptune, a situation that has caught the consideration of researchers and space devotees the same. Eminent figures like Neil deGrasse Tyson and Michio Kaku have voiced their stresses over the possible ramifications of this divine experience. Yet, how did Pluto's way lead to a potential crash with Neptune? And what might such an occasion mean for Earth? Go along with us as we investigate the complexities of Pluto's excursion and why researchers are progressively worried about this grandiose oddity. Once hailed as an undeniable planet, Pluto went through a huge renaming as a bantam planet, generally because of the sporadic nature of its circle. In spite of its downgrade, Pluto continues to charm and interest those inside the galactic community. Late alerts from conspicuous researchers, including Neil deGrasse Tyson and Michio Kaku, have suggested that Pluto's circle could meet with Neptune's, raising the likely risk of a crash with extensive ramifications for our planet. Pluto's circle around the Sun is momentous, attributable to its unmistakable elements. Its circle is extraordinarily extended, requiring a shocking 248 years to finish. Since its discovery in 1930, Pluto has not yet finished a full circle. What makes Pluto especially entrancing is the exceptionally curved state of its circle, as a glaring difference to the almost roundabout circles of the significant planets. Moreover, Pluto's circle is shifted at a point of 17 degrees comparative with the ecliptic plane, bringing about a more extreme slope than that of other planets. This mix of tendency and the lengthened circle adds intricacy to its development. An especially striking component of Pluto's circle is its common convergence with Neptune's circle. At regular intervals, during these periods, Pluto's way carries it nearer to the Sun than Neptune, which challenges the normal relative places of the two planets inside the planetary group. Further assessment uncovers that Pluto's circle is a long way from an ideal circle. Rather, it follows an elliptical, oval-like direction, meaning its separation from the Sun vacillates emphatically all through its circle. At its nearest point, Pluto arrives at around 30 galactic units from the Sun, yet at its farthest it stretches to north of 49 galactic units, almost double the distance of Neptune from the Sun. Furthermore, Pluto's circle is shifted at a point comparative with the ways of different planets, adding one more layer of intricacy to its relationship with Neptune. This tendency plays a pivotal part in how Pluto and Neptune cooperate. When their circles run into each other, their gravitational powers collaborate continuously, modifying their directions. This connection highlights the interconnected nature of the nearby planet group, where the gravitational impact of one body can influence the movement of another. With headways and observational innovation, stargazers have had the option to follow Pluto's development with more noteworthy accuracy, prompting a more clear comprehension of its circle and its expected consequences for the general security of the external planetary group. While the probability of an immediate impact between Pluto and Neptune is low, the chance is as yet being painstakingly checked. Researchers are concerned because the results of such a crash could be devastating. Regardless of its little size and far-off area, Pluto remains an object of extraordinary interest for both researchers and space fans. A crucial inquiry arises, however. Why hasn't Pluto crashed into Neptune already? The response lies in the gravitational impact of different planets. Since Pluto's discovery, space experts have been endeavoring to unravel its way. Not normal for most planets, which keep up with relatively steady circles along the ecliptic plane, Pluto's circle stands out because of its lofty point and elliptical shape. The mystery extended when it became obvious that Pluto's circle crosses Neptune's, introducing a likely risk. In spite of this, Pluto's circle remains shockingly stable, exhibiting the intricate mechanics that govern the developments of divine bodies. Concentrating on the interactions between Pluto, Neptune, and the Sun presents an impressive challenge for space experts. Foreseeing their developments requires a top-to-bottom comprehension of how they influence one another's directions. To navigate this intricacy, researchers utilize various concepts such as ASMU libration, scope libration, and VSOP, von Zipper, Steves, Kaplan isolation, to interpret this enormous riddle. For instance, ASMU libration plays a key role in maintaining the stability of planetary orbits. When Pluto crosses Neptune's way, it stays no less than 90 degrees away from Neptune, preventing an immediate crash. Scope libration ensures that when Pluto approaches Neptune or any large planet, it is situated over their way, reducing the possibilities of an accident. The VSOP wavering, named after researchers von Zipper, Steves, and Kaplan, explains why Pluto's circle seems erratic but remains stable over time. Despite the appearance of chaos, there are fundamental patterns that keep everything under control and prevent Pluto from slamming into Neptune or drastically altering its orbit. The concept of orbital mayhem, which refers to the sensitivity of a celestial body's orbit to its initial position, is clearly evident in Pluto's orbit. Even minor variations in Pluto's position or speed can have tremendous impacts over extended periods. Researchers utilize advanced virtual simulations to model Pluto's interactions with other bodies in space, like Neptune, and to explore the effects of even the smallest shifts in its course. In the late 1980s, these simulations uncovered an interesting finding. Despite Pluto's orbit seeming stable, it can still act erratically. A minuscule change in Pluto's initial position or speed could cause massive changes over the long run. However, even with these uncertainties, Pluto's orbit remains stable over billions of years, suggesting that despite its turbulent appearance, it follows a hidden order. The unpredictability of planetary orbits, like Pluto's, makes it difficult to accurately predict long-term changes. These models require highly precise initial conditions, since even the smallest data errors can lead to vastly different results, making precise predictions particularly challenging. Understanding Pluto's orbit is crucial, especially when considering the potential for a future impact with Neptune. This knowledge helps astronomers gain a deeper understanding of the mechanics of the planetary system. Pluto's orbit serves as an excellent example of how seemingly chaotic paths can ultimately achieve balance. Guided by the forces of gravity and motion, it is essential to continue monitoring and studying these celestial mechanics to better understand our place in the universe. Pluto's orbit perfectly illustrates the erratic nature of space. Its rare oval-shaped path leads to unpredictable encounters with Neptune, making it hard to gauge the long-term dynamics of the system. Despite the potential catastrophic implications of a collision between Pluto and Neptune, the likelihood of such an event remains exceedingly low due to the stabilizing factors at play. As noted earlier, the gravitational forces that interact between these two distant bodies help keep their orbits stable, preventing a direct impact. However, the uncertainty surrounding long-term celestial dynamics means that the possibility cannot be entirely dismissed. Should Pluto's orbit shift due to some unforeseen event, or if the gravitational influence of another celestial body comes into play, the outcome could change. In the event of an impact, the ramifications for the solar system could be far-reaching. Pluto and Neptune are both composed of gases and ice, meaning that the collision would likely result in the release of vast amounts of energy, as well as the disintegration of both bodies. The impact would create massive shock waves, rippling through the nearby Kuiper belt and potentially affecting other celestial bodies in the region. Debris from the collision could form new celestial bodies or be ejected out of the solar system entirely. Moreover, the effects on Neptune itself could be severe. Neptune's own gravitational pull could alter its orbit, perhaps leading to an instability in the orbits of other outer planets like Uranus or even Saturn. If Neptune's orbit were to shift even slightly, it could cause a cascade of changes within the solar system, potentially disrupting the delicate balance of gravitational relationships that currently exists. This might even lead to changes in the orbits of some of Neptune's moons, or affect the stability of nearby trans-Neptunian objects. It is also important to consider the broader context of space exploration and our understanding of the universe. While the idea of Pluto crashing into Neptune is an intriguing and dramatic scenario, it highlights just how little we truly know about the long-term behavior of celestial bodies. As new discoveries are made and technology continues to advance, astronomers and space scientists will undoubtedly gain more insight into the mechanisms that govern the cosmos. What we learn from studying Pluto's orbit and its potential interactions with Neptune could pave the way for greater discoveries about other celestial phenomena, helping us understand how planets, moons, and other objects form, evolve, and interact over the vast timescales of the universe. The mystery surrounding Pluto's future and its place within the larger solar system is a testament to the beauty and complexity of the cosmos. While the odds of a catastrophic collision are slim, the continuous study of such phenomena keeps our curiosity alive and encourages further exploration. Whether or not Pluto and Neptune will ever collide, their interactions serve as an important reminder of the ever-changing and unpredictable nature of the universe. Physicist Michio Kaku, known for his commitments to string hypothesis, additionally offers significant bits of knowledge into space investigation. Kaku accepts that concentrating on peculiarities like Pluto's circle is fundamental for understanding the more extensive standards of divine mechanics and hypothetical physical science. He proposes that looking at Pluto's communications with Neptune can assist researchers with guaranteeing the security of future space missions. Kaku likewise stresses the significance of understanding gravitational powers in space investigation, as they could altogether shape how we investigate far-off universes. His work in string hypothesis, which looks to make sense of the key powers of the universe, lines up with his premium in Pluto's circle. A crash among Pluto and Neptune could give crucial information that would add to how we might interpret gravity and space-time regions, key to string hypothesis. Albeit such an occasion would straightforwardly affect Earth, it could offer a remarkable chance to concentrate on the way of behaving of central powers under outrageous circumstances. As space investigation proceeds, the capriciousness of planetary connections turns out to be progressively obvious. The investigation of divine elements, for example, the perplexing gravitational connection among Pluto and Neptune, offers valuable bits of knowledge into the basic laws of the universe. By proceeding to screen and concentrate on these peculiarities, we draw nearer to disentangling the complicated idea of the universe. The gravitational dance among Pluto and Neptune highlights how even far-off planets can apply influence more than each other. These heavenly bodies apply gravitational powers that, over significant stretches, can quietly yet fundamentally shape their circles. While an immediate crash stays impossible, the chance can't be precluded completely, which keeps researchers and cosmologists on alert. Understanding these powers might one day permit us to anticipate and relieve the dangers presented by such enormous occasions. One captivating part of planetary movement is the way seemingly arbitrary or turbulent collaborations can lead to stable, unsurprising examples. This is particularly true in the case of Pluto, whose circle could appear to be whimsical, yet is really represented by exact gravitational powers. These powers assist with keeping Pluto from slamming into Neptune, in spite of the apparent crossover in their ways. The fragile harmony between the gravitational draw of different planets and Pluto's circle keeps the Bantam planet on a consistent, yet complex course. Understanding this mind-boggling relationship is vital to propelling our insight into the more extensive nearby planet group. As researchers keep on examining Pluto's circle, they additionally direct their concentration toward different areas of space investigation. For example, concentrating on frameworks like TRAPPIST-1, which contains numerous Earth-sized planets, assists space experts with understanding how gravitational powers between planets can prompt orbital resonances. Sometimes, these powers can undermine a planet's way, prompting unsteadiness. However, the TRAPPIST-1 framework isn't encountering any crashes as of now. Researchers keep on checking planetary developments within these packed conditions to more readily comprehend possible dangers and their advancement over time. In the meantime, stargazers are likewise spotlighted on understanding the way of behaving of rebel planets, which travel through space without being bound to any star. As our investigation of space grows, The investigation of divine bodies like Pluto and the TRAPPIST-1 framework turns out to be progressively pivotal for expanding our insight into grandiose mechanics. The investigation of maverick planets, which don't circle stars, offers one more layer of intricacy to how we might interpret planetary movement. These planets, floating through space without gravitational connections to any star, present a fascinating test for stargazers attempting to unravel the various ways planets can act and advance in the endlessness of space. Their erratic directions can bring new factors into the generally perplexing dynamics of heavenly mechanics, and understanding them could offer urgent experiences into the development of planets in frameworks beyond our own nearby planet group. The eccentric nature of Pluto's circle provides significant illustrations in how divine bodies can follow apparently arbitrary ways, yet comply with deep, hidden designs directed by gravitational forces. Regardless of its odd, curved circle and varied direction, Pluto remains a demonstration of the precision with which gravity governs planetary movement. By concentrating on such peculiarities, researchers are revealing the governing laws of orbital elements and applying them to other divine phenomena, assisting with foreseeing and making sense of the way of behaving of far-off objects in space. Albeit the opportunity of a Pluto-Neptune crash is small, the very chance keeps stargazers on alert. Understanding the gravitational connection between these two far-off bodies and their ways is significant for guaranteeing that future space missions and investigations do not unexpectedly encounter any hindrances. Despite the fact that a crash between Pluto and Neptune would probably have negligible direct results on Earth, it would still offer a significant chance for researchers to notice the functions of gravity and space-time under outrageous circumstances, potentially offering new information to help ongoing examinations in astronomy. Notwithstanding Pluto's strange way, the investigation of other comparable grandiose phenomena keeps on providing insight into the many mysteries of the universe. As our technology and observational techniques further develop, researchers can refine their models of planetary and orbital behavior. This continuous examination is fundamental for understanding the many-sided dynamics of the planetary group and beyond. Each discovery adds to a more complete picture of the universe's conduct. Specifically, understanding how gravitational powers impact the development of divine bodies provides basic information for planning future space missions, particularly those venturing to far-off exoplanet frameworks or into the external reaches of our own planetary group. One huge part of Pluto's circle is resonance with Neptune. This relationship assumes a key part in guaranteeing the dependability of the two body circles. Despite the fact that their ways cross like clockwork, the gravitational powers among Pluto and Neptune are in a state of harmony so as not to impact the cautious balance between their developments. This is a demonstration of the accuracy with which the laws of physics work, even in the most far-off regions of the planetary group. This resonance forestalls any potential accidents, guaranteeing that the planets keep on coinciding without essentially modifying each other's ways. This multifaceted dance between Pluto and Neptune serves as a reminder of the vast order that supports even the most chaotic-sounding orbital mechanics. While Pluto's circle is a long way from commonplace, it is a great representation of how the universe works with a degree of precision, an order that isn't quickly evident. Despite its abnormality, the planet's way is impacted by the gravitational powers of adjoining bodies, which help keep up with its stability. As we advance in our understanding of the universe, our exploration of celestial bodies like Pluto, Neptune, and others will continue to shape the future of space science. The data gathered from such investigations will allow us to refine our models of planetary behavior, enhancing our ability to predict and understand the various forces that govern the cosmos. One of the most promising aspects of this ongoing research is the potential to unlock new methods of exploration, particularly when it comes to investigating far-off exoplanets and distant regions of the universe. By better understanding the gravitational interactions, orbital mechanics, and other forces at play, we can develop more efficient technologies and strategies for navigating the vastness of space. As space agencies and research institutions continue to monitor and study the orbits and behaviors of distant planets, The discoveries they make will not only expand our knowledge of the solar system, but also deepen our understanding of the underlying laws that govern all celestial bodies. These advancements will pave the way for future space missions, allowing us to venture further into the cosmos, perhaps even beyond the boundaries of our own galaxy. Moreover, as we push the limits of our space exploration capabilities, we will likely encounter new challenges and opportunities that will require creative solutions and innovative technologies. These might include developing spacecraft capable of surviving harsh environments, finding new ways to detect and study distant objects, and understanding the complex dynamics between planets, stars, and galaxies. As we explore the mysteries of the universe, we will continue to refine our understanding of space-time, gravitational forces, and the fundamental nature of the cosmos. The study of Pluto's unique orbit, as well as other unusual celestial bodies, plays a crucial role in advancing our scientific knowledge. It serves as a reminder that even the most seemingly unpredictable and distant objects in space are part of a larger, interconnected system governed by the same laws of physics. These investigations not only provide insights into the past and present dynamics of our solar system, but also hold the key to unlocking future breakthroughs in space exploration. As the field of space science evolves, we can anticipate exciting new discoveries that will challenge our current understanding of the universe. With each new piece of information, we come closer to unraveling the vast and complex mysteries of the cosmos. These advancements will not only deepen our appreciation for the universe, but also enhance our ability to navigate and explore it in ways we never thought possible. In the years ahead, the study of planetary orbits, celestial mechanics, and gravitational interactions will continue to be a central focus for researchers and space explorers as we seek to answer the fundamental questions about our place in the universe.